Yes, this is Venkatesh Prabhu. I'll be discussing about metabolic flux analysis. This metabolic flux analysis is nothing but flux quantifications methods in a biochemical process. If a reactant A is going to be considered, it needs to undergo various steps of reactions. In all these steps of reaction, finally it will give a product at various stages. That what is the rate of reaction it is going to be taking place at every stages, every cycle, steps involved in a cycle that we need to analyze. So how we can able to do this is metabolic flux analysis. So in this, yeah, flux quantification methods. Quantification method is that is metabolic balance. Metabolic balancing. This metabolic balancing ingredient is S into V is equal to R, where S is nothing but stoichiometric matrix. Metric matrix, and the V is nothing but vector of unknown quantity. Quantity, and this R, small r, is nothing but vector of metabolite in metabolite in extracellular cellular accumulation rate. So S is the stoichiometric matrix, V is the vector of unknown quantity, and the R is the vector of metabolite, the extracellular accumulation rate. So we need to form a reaction. It is going to be a cycle of reaction. How we can form the reaction is, let us take a reaction like this. A is going to be enter. It undergoes a reduction reaction with the rate of Ra, and this is going to form the product of B, the rate of V1. Then there is a equilibrium reaction, that is a reversible reaction. B gives C. This is going to be, let us consider V3 plus and V3 minus. B further undergoes the changes in the form of D with the rate of V2, then D undergoes changes C with the rate of V5, then C gives E gives C with the rate of V4. So V1, V2, V3, V3 is in the form of both forward and backward reaction. Then V4, V5. The product which is going to be coming out of the system is going to be like RD, then RE, then the next one is RC. So only one reactant which undergoes the product of RD, RE and RC, RD, RE and RC. That means how we can able to write this is RA is equal to RD plus RC plus RE, that is C, T and E. These are the products which is going to be obtained. So internally there are so many. This is, well, let us consider the rectangular box as the system in which the reactant A undergoes a reduction and it forms a product of RD, RE and RC. How we can able to balance this equation is, let us consider RA first V1 is equal to A gives P, then P2 is equal to B gives T, V3 plus is B gives C, then V3 minus is C gives D, then V4 is E gives C and V5 is equal to D to E. These are all the reactions which is going to be taking place in a system. So when you are writing the mass balance of this, the mass balance under steady state system, steady state condition is the reactant. We will consider the node as node A is minus RA equal to V1. Node B. Node B is V1 plus V3 is equal to V2 plus V3. This is going to be minus, this is going to be plus. Then node C, node A, node B, and node C. Node C is V3 plus V4 minus V3 minus RC is equal to 0. Then RC is equal to V3 plus V4 minus of V3 minus. Similarly, for node D, V2 minus V5 minus Vd equal to 0. That means Vd is equal to V2 minus V5. Then node E, node E is the last one. This is going to be V5 minus V4 is equal to Re. Like this, we need to form the mass balance equation, and this should be solved using a matrix methods. The matrix how we can create for this is let us take V1, V2, V3 plus, V3 minus, V4 and V5. Then this is going to be within the bracket into the whole thing. It is V1, V2, V3 plus, V3 minus, V4 and V5 is equal to minus RA 0. There is no B rate of reaction into RC plus RD into RE. This matrix is when you see the reaction from A, B, C, D, the coefficients we need to mention that as coefficient corresponding to V1 is corresponding to V1 is minus 1, 0, 0, 0, 0 and 0. Next for V2 this is going to be 1, minus 1, minus 1, plus 1 and 0 and 0. Similarly, for the third one, it is going to the coefficients are 0, 0, 1, minus 1, 1 and 0. The next two equations, this is going to be 0, yes, 0, 1, 0, 0, 0 and minus 1. The last equation is 0, 0, 0, 0, minus 1 and plus 1. So this is the matrix. This matrix we need to solve for finding the V1, V2, V3 separately using a computer or by manual methods. V1 equal to what? V2 is equal to what? So on till V5, either by manual or by simulations method we should solve. That's all. Thank you very much.